Alright, mathematicians, let's get started with Bisectors of Triangles, section 6.2. Our objectives are to use and find the circumference of a triangle, use and find the incenter of triangle, and by the end of the lesson we should be able to answer what conjectures can you make about the perpendicular bisector of a segment and the angle bisectors of a triangle. Here are some basic terms to make sure you know the definitions for today's section 6.2. So take a moment, pause the video, and write down your definitions. Alright, our next vocabulary key term is circumcenter. A circumcenter is the point of concurrency of the three perpendicular bisectors of a triangle, which means that if you construct the perpendicular bisector of all three sides of a triangle, they will meet at a common point, which is called a circumcenter. Other properties of a circumcenter is that it is the center of a circumscribed circle. This means that the center of a circle that the triangle would be inside of, so that all vertices of the triangle are touching the edge of the circle. Also, our circumcenter is equidistant from the vertices of the triangles. The purple segments are the segments that are the same length. So here we have a mnemonic to help us remember that the circumcenter is the intersecting point of all perpendicular bisectors. So think of peanut butter cup, the P, the B, and the C for perpendicular bisectors, and they meet at the circumcenter. Alright, this leads us to the circumcenter theorem. The circumcenter of a triangle is equidistant from the vertices of the triangle. This means that if segment PD and segment PE and segment PF are perpendicular bisectors, alright, so added the perpendicular symbols, then PA equals the length of PB, which equals the length of PC. So all our red segments are congruent. Alright, let's take a look at a real-world problem. 3 snack carts sell frozen yogurt from points A, B, and C outside of a city. Each of the 3 carts is the same distance from the frozen yogurt distributor. Find the location of the distributor. Start solving and answering this question by sketching a picture of this situation. So as you can see here, we have our 3 yogurt shop spots, and it's saying that each of the 3 carts is the same distance from the frozen yogurt distributor. So if you were to figure out the perpendicular bisector of each side of the triangle, we know that based on the circumcenter theorem, that the perpendicular bisector of each side will come to a common point called the circumcenter. So we know this point D, we'll label it D, so D is your circumcenter, and we know that it's the circumcenter because when I bisect segment AB, and then when I bisect segment BC, and then when I bisect segment AC, all of the intersecting point will be at point D. Alright, take a moment to read through the text for the solution in words and copy down in your notes. Alright, so to get a better understanding of circumcenter, when you're reading the prefix circum, it means around or about, as in circumference, which is the distance around a circle. So the circumcenter P is equidistant from the 3 vertices, so P is the center of a circle that passes through all 3 vertices. As shown below, the location of P depends on the type of triangle, and we've studied various types of triangle. The circle with center P is said to be circumscribed about the triangle. So let's look at our first picture. An acute triangle, P is inside the triangle. So when I figure out the intersecting points of all the perpendicular bisectors, point P, the circumcenter, is inside the triangle. For an acute triangle, the circumcenter is inside. When I get the perpendicular bisector of a right triangle, they all intersect at a common point on the triangle. So in other words, the circumcenter of a right triangle always appears on the triangle. And for an obtuse triangle, when I bisect all three sides, the intersecting point of all three perpendicular bisectors will be on the outside of the triangle. So a circumcenter of an obtuse triangle will always be outside of the triangle. All right, let's take a look at a second example, finding the circumcenter of a triangle. With vertices at A, 0, 3, B, 0, -1, and C, 6, -10. Step 1, graph triangle ABC. So you will need graph paper for this example. Step 2, find the equation for two of the perpendicular bisectors. Use the slopes of the perpendicular lines theorem, which states that horizontal lines are perpendicular to vertical lines. So after you completed step 1 and graphed triangle ABC, you should see that triangle ABC is a right triangle. And just a study tip, note that you only need to find the equations for two of the perpendicular bisectors. You can use the perpendicular bisector of the third side to verify your results, but once you have at least two perpendicular bisectors, that's really all you need to actually find the circumcenter. The third one would be fine to verify, but it's not absolutely necessary. So after completing step 2, we see that for our right triangle, we have a horizontal line and a vertical line that are intersecting at a common point, which is 3, 1. So equation of this vertical line is x equals 3. The equation of this horizontal line is y equals 1. So the midpoint of segment AB is at 0, 1. That is perpendicular to segment AB, which is line y equals 1. So at 0, 1, the midpoint, we have the line y equals 1. So it is the perpendicular bisector of segment AB. And then the midpoint of segment BC is at 3, -1. And the line through 3, -1 is the perpendicular segment to line to segment BC, which is x equals 3. Third step, find the point where x equals 3 and the line y equals 1 intersect, and they intersect at 3, 1. So, in conclusion, the coordinate of the circumcenter is at 3, 1, because that is where the perpendicular bisectors intersect. All right, take a moment to pause the video and you try these on your own. Find the coordinates of the circumcenter of the triangles with the given vertices. You've got two examples that I want you to try. It will take you a little bit of time, so take time to try these on your own and then unpause the video to check your answers. All right, here are your answers with all of the support, the work and the support, along with the graph and the pictures and labels and nice usage of the vocabulary words that we're emphasizing in this unit. So take a time to copy down any and all of the work you see here for numbers 2 and 3 so that you have these two great examples in your notes. All right, just as a triangle has 3 perpendicular bisectors, it also has 3 angle bisectors. And the angle bisectors of a triangle are also concurrent. So here we have the point of concurrency of 3 angle bisectors of a triangle, and they all come together and intersect at a point called the end center. Also, the end center is the center of an inscribed circle, which means that the circle is inside of the triangle. and each side of the triangle only touches the circle at exactly one point. Also, the incenter is equidistant from each side of the triangle, as represented by the dotted purple lines. Our next mnemonic to help us remember that angle bisectors intersect to form the incenter is the words apple butter instead. And later we'll put all the mnemonics together with a cute little phrase. All right, our incenter theorem states that our incenter of a triangle is equidistant from the sides of the triangle. So in other words, if segment AP and BP and CP are angle bisectors, then length PD equals length PE, which equals length PF. And notice each of these lengths are perpendicular segments to the sides of the triangle. Super important. All right, let's take a look at example 3 where we can use the incenter of a triangle. In the figure shown, length ND equals 5x minus 1, and length of NE is 2x plus 11. Find NF, and can NG be equal to 18? Explain your reasoning. So let's first label our picture with the information we're given. All right, after we label our picture, note that N is the incenter of triangle ABC because it is the point of concurrency of the three angle bisectors. So by the incenter theorem, we can conclude that ND equals NE, which equals NF. So all three angle bisectors come together at a common point. That common point is called the incenter. So N is our incenter. Therefore, length DN equals length EN, which equals length NF. This means next we can solve for x. And because all three of these segments are congruent, we can say that 5x minus 1 equals 2x plus 11. Solve for x, so x equals 4. Use substitution to find ND or NE, they're the same. So ND equals 5x minus 1, substitute 4 for x, and solve to get 19. So because ND equals NF, NF equals 19. Next, we want to recall that the shortest distance between a point and a line is a perpendicular segment. Super important. In this case, the perpendicular segment is segment NF, which has a length of 19. Since 18 is less than 19, NG is equal to 18. All right, let's take a look at another real-life problem. A city wants to place a lamppost on the boulevard shown so that the lamppost is the same distance from all three streets. Should the location of the lamppost be at the circumcenter or the incenter of the triangular boulevard? And then please explain. To help you decide whether it's going to be the circumcenter or the incenter, you want to pay close attention to the mathematical language. The city wants the lamppost to be the same distance from all three streets, not from where the streets intersect. There's a difference. Alright, since the shape of the boulevard is an obtuse triangle, its circumcenter lies outside the triangle. So the location of the lamppost cannot be at the circumcenter. The city wants the lamppost to be the same distance from all three streets. By the incenter theorem, the incenter of a triangle is equidistant from the sides of a triangle. So the location of the lamppost should be at the center of the boulevard. That concludes 6.2, so keep calm and love math. Well, if you don't love math, at least appreciate it. The end.